This is 2.2 graphing quadratics in standard form. Okay. So we've already discussed the characteristics of a quadratic equation, and we're just going to look at them in the standard form. So we should have our guided notes with us so we can kind of follow along. Okay. Now the general form of a quadratic equation is y equals ax squared plus bx plus c, where a, b, and c are actual numbers, okay? A is always the number in front of the x squared, b is always the number in front of the x, and c is the number of the constant all by itself, no variable whatsoever, okay? Now, to be a quadratic equation, you could be missing the bx part or the c part, either one. So they may not all of them have it, but they all have to at least have the x squared part, Okay, and if you don't see a number in front of the x squared or the x value, you're understood to be 1, okay, your coefficient, all right? All right, so let's take a look at number 1. We're going to sketch the graph. Now, we have sketched these already by doing t-charts. Remember t-charts? And we just plug a bunch of numbers in and then plot them and do a nice curve. Well, we're going to make this easier on you, a little bit quicker. So that's what we're learning for the next, for the rest of the week, is just quicker graphs of these, all right? Just be quicker about it, all right? So one of the important features is that we have to identify the vertex. All right, that is an important feature. But we know the vertex also goes through the axis of symmetry. So the axis of symmetry. Now, the axis of symmetry has a formula when you're in standard form. It is x equals negative b over 2 times a. All right. You need to have that available to you as you're doing this assignment. So you need to know that. So in this case, you have ax squared plus bx plus c. So the a is 1 and b is negative 6. So the opposite of negative 6 is a positive 6. So it's always the opposite of whatever b is, okay? So if it's positive is negative, negative is positive.
So the axis of symmetry is negative 6 over 2a?
Over 2 times a, yes. Negative, or that's negative b. That's a b. It's a formula, okay? Just like mx plus b is, or like the area of a triangle's a equals 1/2 the base times the height. Same idea, okay? We just got to
2 times a.
2 times a. And what is a? 2 times a is the coefficient in front here, and we don't have 1, so it's understood to be 1. So we plug in 1. So that is 6 divided by 2, or 3. So x equals 3 is the axis of symmetry. Now I'm going to sketch it just so we can have a visual that we know that our parabola, our quadratic equation, is symmetric around that line. Okay, symmetric around that line. Now the vertex. Now your vertex lies on that line, right? So we can steal that x value. So it's 3 comma something. I don't know what that something is. All right. So what I'm going to do is I'm going to take that 3 and plug it back into the equation. Okay. So I'm going to do a little like think cloud right here. So y equals x squared, which we know x is 3, so 3 squared, minus 6 times 3 plus 13. So that is 9 minus 18 plus 13. I'm going to not write that out because I'm running out of room. So we have, maybe, we have 9, oh, stop, 9 minus 18 plus 13 gives us 4. So our y value here is 4. So we're going to graph the point 3, positive 4. Okay, that is our vertex. Now we're going to make another note. Since our a value, that 1 right there, right here, since this is positive, we know it's U-shaped up, okay? So let's make that note. We know it is, it opens up, okay? So we know it's U-shaped up somehow. So there is a couple, we could do a t-chart, okay, and then reflect if you want to. But since that coefficient is 1, and this happens for all coefficients are 1, if we go over 1 unit, what is 1 squared? Is 1. So we're going to go up 1. So there's our second point. Reflect it. Okay? That's kind of like home base. We know it's no wider or narrower than the original. It's just like the original. Okay? And if you want to do this again for another point, now 2 units over to the right, what is 2 squared? Height of 4, right? So if I go up 4, 1, 2, 3, 4, there's another point. And that is a pattern that happens with all parabolas. Okay? The 1, 4 is a constant. 1, 1, and then 2 and 4. So you can think about that as like kind of like the starting points. Does that make sense? Like the slope kind of type thing, but this is in parabolas. And it's just a quick way to get a couple points, and I would suggest you use that method. Could you have done a t-chart? Absolutely. But it's just much easier to remember 1, 1 and 2, 4. Go over 1, up 1, put a point. Over 2, up 4, put a point. Okay? Because this parabola is not being wider or narrower. It's just like the home base one. Okay? All right, let's look at number 2. All right, so let's take a look at, we don't know the vertex, but we know we can find out the axis of symmetry, which will give us part of the vertex. It is negative b, x equals negative b over 2 times a. B, oh, yep. Oh, hold on. There's my mouse. There we go.
Does that say negative 6 over 2a, 2 times a?
Negative b over 2 times a?
That's what I meant.
Yes, it's okay. Okay, so the opposite of b, now let's label, I'm going to label above, ax squared plus bx plus c. Okay, opposite of b, which would be negative 8 over 2 times a, and a in this case is just 1. Okay, we're starting out with just 1. So negative 8 over 2 is negative 4. So x equals negative 4 is your axis of symmetry. So it is symmetric around this vertical line right there. Okay. We're going to steal that value. I'm going to take it up here. The vertex starts with negative 4, comma something. I don't know what that is. So I need to plug it in. So I'm going to just a little side work here. Okay. So I'm going to plug negative 4 into my equation. Now, negative 4 is 16. I'm just going to use my calculator. So negative 16, nope, not negative 16, positive 16. Negative 4 times negative 4 is a positive 16. Plus 8 times negative 4 plus 18 gives us 2. So we get the vertex negative 4, 2. Now make another note. Notice how the a value is positive. So this opens up. And let's write that. Let's write that at the top of our paper. So if a is positive, it opens up like that. If a is negative, it opens down. It's U-shaped down. Okay? So it kind of gives you an idea of what it's supposed to look like. All right. All right, so now their coefficient is 1. So we can just do the 1, 1, 2, 4 thing. Okay? So let's do the 1, 1. Over 1, up 1 from the vertex. Plot a point, reflect it. And then let's do the 2, 4 things. Over 2, up 4. Plot a point, reflect it. Draw a nice smooth curve down through those 5 points. 5 points is a plenty, okay? 5. right, let's take a look at number 3. Okay, so we do not know the vertex yet. Vertex is like I said, it's the most important thing, but we do know how to find the axis of symmetry. We find the axis of symmetry by doing our formula, x equals negative b over 2 times a. Axis of symmetry, x equals negative b over 2a. So what we're going to do is we take the opposite of b. Here's b, so negative 4 over 2 times a. A is just 1 because we don't have anything in front of the x squared right now. That's not always the case. It's going to change probably tomorrow, but right now it's just 1. So this is 4 divided by negative 2, which is just negative 2. That is the axis of symmetry. So let's graph that. And for our vertex, we're going to steal that x value, negative 2. We're going to plug it into the equation. So y equals negative 2, parentheses negative 2 squared, plus 4 times negative 2 plus 5. Again, you can plug it in your calculator, you can do it in your head. So that's 4 minus 8 plus 5, I think that's 1. 4 minus 8 plus 5, it is 1. So we get the vertex of negative 2, 1. And this opens up because A is positive. Now, they don't always open up, okay, but we're just given a certain type today, okay? Now, we're going to do our little trick, our little 1, 1, 2, 4. So 1 over 1, up 1. 1 squared is 1, so that's our point. Reflect it. And then over 2 units, 2 squared is 4, so we go up to 4 units. That's 1, 2, 3, 4. 4 blocks, okay, not just up to the number 4. We go up 4 units. So we rise 4 and put a point and reflect it. And there is our parabola.